Good morning, kids. This is Mr. Agee for math today on Tuesday, September 22nd. And the focus of our lesson is here. Use the distributive property as a strategy to find related multiplication facts. That sounds like a lot of words, but you have seen these things before. The distributive property is useful for breaking larger problems into smaller problems so that you can use friendlier numbers. And since we've been working on the threes and the fours this week and the beginning of the end of last week, we're going to be breaking a lot of these problems down into threes and fours to continue practicing your ability to multiply by 3 and multiply by 4. So we're going to use the problem set to work through this. If you don't have your green book out and ready now, please pause the video, get your green book, and open it up to the Lesson 16 problem set. It looks like this. Okay, what you will see here is we've got an array model to represent a problem um, in each of these quadrants of the page. So the page is divided into 4 problems, and the directions are label the array, then fill in the blanks below to make true number sentences. That basically means make sure your equations are balanced and that what you have on the left equals what you have on the right. So let's just take an overview here. We've got 6 times 4 is the first problem, 7 times 4 is the second problem, 8 times 4 is the third problem, and 9 times 4 is the fourth problem. Now, if we're using our reasoning skills, we'll know that once we figure out this one, for 6 times 4, all we have to do is add one more 4 to get 7 times 4, add one more 4 to get 8 times 4, and look at the ninth multiple, one more 4 to get this answer. But the point of this is not to just know the answers. The point of this is to practice using the distributive property to help you break bigger problems into smaller problems. And what you'll notice is they have used the same exact friendly problem in each of the 4 examples here. So they break 6 times 4 down into 5 times 4 plus 1 times 4. They break 7 times 4 into 5 times 4 times 2 or plus 2 times 4. So we've got 5, the first factor is 5, and then the first factor is 1, giving us a total of 6. Here we've got the first factor is 5, and the second part is the first factor is 2. When you put 5 and 2 together, you get 7. Then they do it again. 5 times 4, they use it again. In the last problem, they use 5 times 4 again. So they're giving us the same starting point in each one of these problems to emphasize, hey, we already know our 5s. We started skip counting by 5s before we even got to 3rd grade. So this problem is a friendly problem, and we can find that friendly problem inside these harder problems. So let's get started. So we've got 5 times 4. So they've broken 6 times 4 into 2 separate arrays. So they've got the one big array, and then they put the dotted line here to show that we're going to break this into 2 smaller problems. We've got 5 times 4 here. We've got 5 rows of 4. And if I wanted to use my count by, I could label a 4, an 8, a 12, a 16, and a 20 right here to know that I'm at 20. Or I could count by the columns because I know how to count by 5s. 5, 10, 15, 20, and that would take care of the darker gray portion of this array. Now I've got the bottom section here, and we know 1 times anything is that number. So 1 times 4 is 4. So I'm going to go ahead and put my 4 in there. And now let's look at it, how they have it broken down. They've got the original problem, 6 times 4, and that equals the broken down problem, the 2 easier problems added together. So the 5 times 4 they figured here is 20, and then the 1 times 4 we just figured out is 4, and we put those together. We will use a cover 0 strategy, which we'll talk about in person. We're covering that 0 up with the 4, and we've got 6 times 4 equals 24. We're going to put it right up here. 6 times 4 is 24. So now automatically we're going to know, okay, the next one is 7 fours. This one's 6 fours. So 7 fours is going to be just one more 4 than 6 fours. So we'll go ahead and put the answer on there. We know that 4 more than 24 is 28. But that's not the point. Remember, the point is to practice using this distributive property to help us solve bigger problems. So when you face 7 times 4 and you don't automatically know that it's 28, then you need some strategies to help you figure it out. So our strategy for this day is to practice the distributive property, to break up 7 times 4 into two smaller problems. So we've got 5 times 4 again, and we don't have to think too hard about it because we've already done it. We know that 5 times 4 is 20. You know, when I do this kind of stuff, I do it out loud because of that brain quality, that the more ways your brain takes in information, the more you're going to understand it and remember it. So speak it, do it. The act of saying it is another way for your brain to remember, in addition to writing it or typing it. So I've got the top portion here of the array as 5 times 4 equals 20. And now the bottom portion I could do a count by is 4 and 4, or 2 4s make 8, like this. And now I just go down here and I see, okay, the big problem is in bold here, 7 times 4. They broke it up into two problems, 5 times 4 and 2 times 4. And so now we're going to put the products here. 5 times 4 is 20. And 2 times 4 is 8. And when you put those together, they already gave you the answer here, 28. Okay, so I'm always running out of time at the end here. I'm going to skip ahead a little bit. Now, your assignment after we go through this is to do the homework that's associated with this. So the lesson 16 homework is your assignment after you watch this video. You'll go into the Schoology page, you'll click into the assignments, you'll go to math, and after doing that lesson 16 homework, you're going to take a picture of it and drop it into this media folder here so you can show me that you have done your work. So this is a different way to submit your assignment. So it's not on Kami, it's actually taking a picture of the assignment that you have completed and posting it into the media folder. All right, back to the work. In your green book, we're turning the page. They've got match the equal expressions. I found out that the picture wasn't there in your workbook for one of the previous assignments. I hope it's there. I don't have a copy of your workbook, and I'm not in the class with you, obviously, so I don't see that you don't have it, but I'm hoping yours looks like mine here. It says match the equal expressions. Well, we've got 5 times 4 plus 3 times 4, so it's already broken up in each one of these little clouds. And the bigger problem is here in the balloons. The hot air balloons has the bigger problem. So it looks like they're all times 4. So we've got times 4, times 4, times 4, times 4. So we're looking at the first factors. And when I look at the first factors here, I'm going to use this line feature. So I'm going to say the 3, okay, and the 5, when I put those together, I get a number. I get the number 8. Can't see it there, so let's see if I can move it. Oh man. Okay. There we go. So 5 and 3 make 8. So this is 8 times 4. So my connection here is going to be from this cloud to 8 times 4. The same here. So I can say, okay, the first factor in this one is 5. The first factor in the second part here that they broke out is 1. And so 5 and 1 gives me 6. And so now I can use my line feature to take this one to 6 times 4, like this, and so on and so forth. You can figure out the last two. Now we've got a problem that involves the distributive property here. we're going to visualize it like we usually do and use the read, draw, write like we usually do. Nolan draws the array below to find, oh, if you have to read problems on your own, don't forget to use the text-to-speech feature here to read the problem for you. Excuse me. I'll read it. I'll read it for the sake of time here. Nolan draws the array below to find the answer to the multiplication expression 10 times 4. Remember, an expression does not have an equal sign. An equation has an equal sign. He says 10 times 4 is just double 5 times 4. Explain Nolan's strategy. Okay, so I have to think, okay, what does this word double mean? I'm going to highlight that because I got to make sure I understand what double means. I'm going to go ahead and highlight this word double, and I don't know why it's and I'm going to just make a note here that double is just the same as multiplying it by 2 times. Okay, so I'm marking up the text. That's called the MUT strategy, mark up the text. And he's saying 5 times 4 2 times. Okay, so I think I know what he means. He's saying that 10 times 4 is the same thing as 5 times 4 added to another 5 times 4. We're going to do 5 times 4 2 times. Double it. We're doubling 5 times 4. So we're doing it once, and then we're doing it a second time, doubling it. So now we have to figure out, okay, what's 5 times 4? Well, fortunately for us, we were able to do 5 times 4 numerous times in the top section of this. We've got here 5 times 4. We could count by 5s, 5, 10, 15, 20, or we could do our count by with 4s, 4, 8, 16, I'm sorry, 12. I'll start over just so as not to confuse you. 4, 8, 12, 16, 20. Okay, so both ways we get 20. I'm going to put my text box in to show that 5 times 4 equals 20. And then down here, we've got the same thing. 5 times 4 equals 20. I could spend the time drawing it in, but I'm starting to run out of time. I always feel the heat when I get around 12 minutes because these videos are only 15 minutes long. That's the maximum amount of time I have. So here we're doing 5 times 4 equals 20. And so down here, what I'm going to do is I'm going to put another text box, and I'm going to put equals. The sum here is 20, and then I'm not the sum, the product of the first multiplication problem is 20, and the second problem is 20, so I'm looking at 20 times 20, and so now I can rewrite the whole thing here and do 10 times 4 equals 40. Now, I don't think this is a great example here, and I would want on your in your notebook, I would want you to circle this to show me that it's the answer. It says explain Nolan's strategy. The correct explanation for the strategy would be Nolan used the distributive property to make a big problem into a small, I should say to break a big problem into two, I'll use numbers, two smaller problems. So he broke them up and put them back together again. It's Humpty Dumpty's happy ending. That's what we like to call the distributive property. Break them up, solve the smaller problems, and then put them back together for the larger problem. Now, what I was saying is this is not a great example because 10 times 4 is actually a pretty friendly problem as it is. Anything times 10 is a pretty friendly problem. So I probably wouldn't recommend breaking up the 10s because we can count by 10s and we've been able to count by 10s for a long time. In any case, your assignment is to do the lesson 16 homework, take a picture of it, go into the math folder, and then snap and upload your picture into the media folder.